Hello friends and welcome to my channel. So in this episode we're gonna talk about rectifier tubes because I got a question from Hugo Bloemer, and he saw this video on my Type 47 amp, and it uses two rectifiers, and he had a question on it, so I'll read it out to you. So what this says, Hugo, and by the way Hugo, thank you for your question. So the questions I have are regarding the tube diodes that you use. Could you please elaborate on the considerations you made with choosing the rectifier in the bias tube? I think that will be an interesting topic, and I hope I'm not the only one to do so. And what he's talking about is that there's a bias tube here, a rectifier is used for bias, and there's one here for rectification, and the two of them had very different they have very different characteristics, and they were chosen for very different design goals. Now, what things didn't go into it? If you look at the comments on this video, you'll see a short discussion I have with Frank there, and Frank actually says that each of the rectifier tubes has its own characteristics and an ideal working environment, and so a little bit went into my design with that, but probably not as much as the level that Frank is aware of. So you can read those comments. That didn't go into it, so I hope Hugo, that doesn't disappoint you too much. There is difference between tubes. You will get rectifier tubes where it, for example, says, you know, this one has a gray plate, and I've got another version that has a where is my other tube here? You know. And this one has a black plate or something. Now these are triodes, but just as an example. So that didn't went into it. Also, as you noticed, I didn't actually match the period style with these tubes. So I didn't go with this type of ST model, which would have been much nicer. You know, and I think as I move forwards to a more final version of this amp, I will look for a directly heated rectifier tube there, and maybe even there. So and something that is time period correct, probably an earlier rectifier if I can help it. So the aesthetics and its working environment didn't go into it just so much, but it had very different criteria, these tubes. So, and where does that start? A lot of it has to do with the specs of the tube. And you know, when you go to a tube, a rectifier, like here I've got a rectifier here, data sheet, it has certain characteristics, how much current it takes, what it likes as a heater, and some maximums, so the maximum current and the current deliver, and also very importantly, it has a graph usually to say how much each diode in you know, whether it's a half wave or a full wave rectifier tube, how much voltage it drops for a given current. So if you look at this tube, you can see at 100 milliamps it drops 8.5 volts. At 50 milliamps it drops 5 volts. So there is a bit of a progression here. So generally, as it conducts more current, it will drop relatively a bit less current. But it will still drop more and more voltage as you require more current for it. Now this tube in particular for a tube rectifier has a particular low voltage drop really. And as you'll see, I had very different requirements in that regard for this. Now where did this start? Well, on both ends I can actually do the calculations from the working point that I wanted. So the working point of these tubes was I needed 250 volts from cathode to plate on this, and I wanted to have a bias, so the voltage difference here is of 16.2 volts. And this tube draws 30 milliamps, and this tube draws 30 milliamps. So 60 milliamps in total goes through the power supply and needs to be fed here with the rectifier tube. And here I've got also 60 milliamps and it needs to drop 16.2 volts. Now what I usually then do is as I said, if you see these data sheets, if you do this more than once, and I have built of course many versions of this type of, where I use a rectifier tube for the bias, for the common bias, I have actually put this data into a spreadsheet. So I know at every point how much, if I need a certain voltage drop, how much current this a particular type of tube will drop. So this is my spreadsheet for this. So as I said, I knew I needed 30 milliamps in over 2 diodes spread, so 30 over one diode, 30 over one, or I use just one diode and it needs to conduct 60 milliamps while dropping 16.2 volts. So that was my requirement here for my bias tube. So I looked then in my spreadsheet, what I'll just do is I highlight my column with 16 volts and I look on tubes that either have 30 or 60 milliamps. So if you look here, so I found a tube here that has 26, which is not quite 30, and you know, I've got the tube here 40 that conducts way too much. Like if I look at this, the 6Z4, I only get 14 volts bias at 32 milliamps. You know, and usually, by the way, when I choose I use this table, I'd rather have a rectifier that conducts a little bit too much, so that when I lower the heater voltage, it usually starts conducting a bit less, and so I can tweak it a little bit, and then the tube will live longer. So with indirectly heated tubes, that's really not a problem. You just, you know, you just tune down the heater a bit, and you get the perfect value that will work. Another tube, which by the way did comply with the Aesthetics Commission, but I didn't have it in stock, would maybe be the 5U4GB. So because I saw it actually conduct 70 milliamps when, but then it for a 20 volt voltage drop, so that might also come quite close. It's not exactly ideal, so there might be a tube, and this is also a directly heated tube, so that would maybe a candidate in the future. But what I settled on was this tube, so the 6BW4, as you know, and it did 26, so that's not quite enough. Now, I didn't feel like increasing the heater to improve the conductance. I had actually hoped that I found within my tube stash, within the 3 or 4 models, tubes that I have, the 6BW4s, that there would be one that just conducts more, because usually there's quite a spread between the values when you get several of them. But in my case, they were all extremely similar, so I was highly surprised. So I didn't have one in my collection that, yeah, they were all very close to this 26 milliamps. I tried 3 of them and they were all virtually identical. So what I ended up doing is still using this, so 30 milliamps on each of the diodes here and here, and then I bypassed it with a 680 ohm resistor, just one, and that just provided that extra missing 4 milliamps of conductance that I needed, and that worked out perfectly with the bias. It actually is 16.2 volts, exactly what I wanted it to be. So on the other end, you can do the same with the voltage drops, because you know, given 60 milliamps, how much it drops through these two chokes, and you also know what is. And then if you were, say you are not a, you know, if you do a full new design and you're a manufacturer and you can order things on, or you're able to order exactly spec'd transformers, not standard transformers, then you can just really go with any tube type that is most optimal, maybe sounds optimal for your design, and then you just order the power transformer with the right voltage, because you know exactly what you need. Because and by the way, this is especially in this amp design, because this is a differential amp, the power draw is near constant, so I'm not working with very dynamic conditions in my amp. it's all very predictable, so you can very easily do all the calculation. It is actually, you know, bloody simple, and so you can work that way. However, in my case, I had a power transformer that didn't have much headroom for what I needed here. So I knew it would be tight. So what I was looking mainly for is something that, unlike this, which drops a lot of voltage, I needed something that dropped at as little voltage and was preferably in my stash, in my collection of tubes. Luckily the EZ81 ticked all the safety boxes, so it can easily deal with a 450 volts voltage difference even between the heater and the cathode. I also have it on a separate 6.3 volts winding, so it doesn't need to share the power supply with the other tube. It's on its own winding, so it was very easy to electrically make this so that you don't get any arcing and so on. So that was easy for me. It dropped to low enough voltage, and also given the operating conditions, so given the impedance of the power transformer and also the impedance of this first choke, which is quite high, 275 ohms. So even though it's a 40 Henry choke, it's 275 volt. And I also preceded it by a 15 ohm resistor after the tube. So it is in a working environment where it can really easily deal with the peak currents that it actually needs to deal with it. So the power draw is not extreme, it's well within the limits of this thing, and the power drop itself is low. Now, when I first put it together, I didn't have this cap in, and it turned out I only got like about 230 volts over this pentode, over the Type 47. So I added in the capacitance, and I had to add in a 2 UF capacitance, probably optimal is probably 1.8 or so capacitor here, and that brought the voltage up a little bit, and just enough. I could tweak this to actually get exactly the right voltage there, and still the operating conditions for this tube were well within spec. So those were my considerations. So a couple of things, just to finish this subject off. If you're a tube roller and you have, for example, you have bought an amp with warranty on it and so on, this, you know, changing your rectifier is probably the only knobs you have to change the sound and the working point, and without voiding the warranty, really. So that is a very different, and their storage is just because they can't, for example, allot the cash that they have or the money that they have to improve the sound. They won't optimize anything else, because they won't touch the other components in the amp. You know, but you can change the tube. So that is a very different story, which I'm not really into here. And yes, all of that makes a difference, and you can find one that is just optimally with the tube combination you have. Then the other thing, as I said, is just a really full end designer, but as a DIY you often work with limited means and with specific components. So then the making it work has your compromises shift into a different direction. The other thing is also some designers, of course, like to create an amp that is a bit saggy and warm, and for example they intentionally use a tube that with an amp, for example, that is in class AB or that has variable power draw while it's operating, and so it will be intentionally, they use a tube with a high voltage drop so that the dynamic peaks are, they're rounded off. They can't quite deliver the power. You know, those are the amps that are called slow and so on. So when you're designing for such kind of considerations, of course the whole choice becomes very different, because you need these components not to fulfill an optimal role where they get out of the way, which is my approach in amp building, and that pervades my choices, but then you're chasing specific effects, specific tastes, specific colorations, and then your choices become, of course, very different. So that's not what's going on here. It is a bit a question of making do, but I know as I go to take this design to a more final state, as I said, the type of tube will be more oriented towards sound quality, while still fulfilling all the working points. And when I order a power transformer, it may be also a custom power transformer, also with custom. I've always got the tweak anyway, but I want it to be an inductor-led design. So it will progress. I will do a more time period correct type of rectifier, use that. But unfortunately, now it was really actually quite reasonably one-dimensional, albeit with very different goals and requirements here. So Hugo, I hope that answered your question. I hope for everyone else as well that it was somewhat interesting, is just taking one element out of amp design. As said, the philosophy that you have in your amp building will severely dictate your choices and what you do with it. But yeah, I think that's it. Thank you for tuning into my channel. Thank you for your attention. And I'll hope to catch you in a next video. And until then, please have a brilliant day, brilliant night, brilliant week. And see you soon. Bye bye.